Okay, a boat travels 210 miles downstream in 10 hours. The return trip upstream takes 70 hours. Find the speed of the current and the speed of the boat in still water. Okay, so I've got two diagrams here. On the left is the trip downstream. So the black arrow represents the speed of the boat in still water. The blue arrow represents the speed of the current. When you're going downstream, those two speeds get added together and you go faster. And on the right, I've got my river showing the return trip. And notice that when you return, now you're fighting the current. So you're going to go slower. And I guess really my arrow here, the black arrow, should be longer because you have to go faster than the current to make it back at all. So maybe I should fix that here as well. Okay, so that's the idea here. Can I scroll on this? I guess I just add a new board. Okay, so let's use the general formula. Distance equals rate times time. So you know your distance was 210. And the rate when we go downstream, well, it's going to be the rate of the boat plus the rate of the current times your time, which was 10 hours. And then the return trip, it's the same distance, but now remember the rate, now the current is working against the speed of the boat. So our overall rate is B minus C, where B is the rate of the boat in still water, and C is the rate of the current. And our time is 70 hours. So we have a system of equations that we can use to solve for B and C. So why don't we start by distributing the 10 in that first equation. So we got 10B plus 10C. And let's distribute the 70 in our second equation. So we got 70B minus 70C. Okay, now I notice this one, I could just divide both sides by 10. So I'd have 21 equals B plus C. And here I'd have 21 equals 7B minus 7C. Okay, so let me add another board here. Let's go ahead and take that first equation here and multiply it by 7. So what is 7 times 21? That's 147. So we'll have 147 equals 7B plus 7C. And the other equation was 21 is 7B minus 7C. So since I did that, now I can add the equations together and notice that the C variable, the C unknown, will be eliminated. So what is 147 plus 21? That is 168. 7B plus 7B is 14B. These cancel, they're eliminated. So now I can solve this for B. I can divide both sides by 14. 168 divided by 14 is 12. So the boat rate is 12. What would the units of that be? Well, our distance was given to us in miles, and our time was hours. So this would be miles per hour. And that's the rate of the boat in still water. Okay, so let's find C, which maybe for that, let's use 21 equals B plus C. And now we know the value of B. So we can plug in 12. And now we can solve that for C. We can subtract 12 from both sides. So C would be 21 minus 12, which is 9 miles per hour. So now we have the rate of the current. And then lastly, it might be a good idea just to check that. So the current is 9 miles per hour. The boat speed was 12. So if I go with the current, I'm adding my two speeds. So I've got a speed of 21 miles per hour. So if I take that rate, 21 miles per hour, and multiply it by, what was it, 10 hours? Then I should get my distance. Remember, distance is rate times time. So my distance is going to be 21 times 10, which is 210 miles like I expected. Now the return trip, now the current is working against our boat speed. So the overall rate is going to be 12 minus 9, which is 3. The time we know it took us 70 hours. 3 times 70 gives us 210, which is the distance we expected. So we can be confident in our answer. Okay.